All right. Well, apparently, my battery in my laptop died last night. Apparently, my charger died, and apparently, I never saved what we were working on. I just kind of relied on me being able to always close the laptop lid and stuff like that, which seems very strange. I'm usually pretty good at. Well, no biggie. It'll take a second to bring it back. So we'll create a new project. And what we were using in the swamp. And our assignment for this one was to have the the little shrine guy comes up with a number. The witch gets 10 guesses, and each time the witch guesses, the witch has to the shrine lets the witch know whether she was right or wrong, and then tells her whether she was too high or too low, and then the witch updates the guess for the next time around. Okay, so let's get our witch back out here and all that stuff. All right, there's our witch. That's the witch, and then was a shrine from the same thing here. Was it a different? Was a different. Far East. And then we need to do resize. Little baby shrine. Okay, there we go. All right, so now we want to go ahead and have that. We got to go back to our code here, and we're going to have our shrine come up with a secret number, right? So that's this guy. Click on our shrine, add a property. So this guy was a whole number. What do we call it? Secret number. And we'll initialize it to -1 for no good reason. All right, and then initially our witch has a guess, correct? So we'll go into our witch, we'll add a property, also going to be a whole number, and we'll call this our guess. Initialize that to -1. Okay, so now what we want to do is we want to have the witch guess 10 things. So let's just start with that real quick to get the ball rolling. So we're going to do something some number of times. In this case, we'll do it 10 times. There's our loop. And what are we going to do each time? Well, we're going to have the witch set her guess. Just put a 0 in there for right now, but we're going to change that to a random integer between 1 and 10. All right, and then let's go ahead and just have our witch say their guess for right now, just to make sure everything is zigging when it was supposed to be zigging. So we'll have this guy. Say hello for right now. We're going to change this to my guess is, and then this one will be the witch's actual guess. So the witch will make a guess, then she'll spit out what her guess is, so on and so forth. We'll add a little delay in each one of these, so she'll say the guess for half a second, so this doesn't take too long. 2, 6, 5, 7, 3, blah, blah, blah. Okay, So now, just so I don't forget, let's go ahead and save this. Let's see where I'm going to put this. Let's put it in my Dropbox, CW. And let's create a folder called CSC200 Alice Projects. And we'll call this which project? Okay, so we're going to go ahead and have the witch make 10 guesses. Now each time when the witch makes her guess, we need to compare that against the shrine's secret number. So we'll go ahead and we're going to teach our shrine. We already gave it a secret number, right? We gave it a property for secret number. So we selected our shrine. We're going to go and we're going to set the secret number. We're going to do this before that loop. I'll start off at 0 and then we'll update that to be a random number between 1 and 10. Alright, so our shrine's going to set a number between 1 and 10. Then we're going to give the witch 10 tries of finding that number. And then we're going to, so the witch is going to make her guess. Now we want to find out if the witch guessed correctly. So we're going to ask a question. Put it right here. So if what? If the witch's guess is equal to the shrine's secret number, then we're going to say you got it. And I think that'll take us where we were before. So if this whole number and this whole number are the same, and the first whole number we're going to use is going to be our shrine's get secret number. And the second one we're going to use is our witch's get guess. If they're the same, then we're going to have the shrine say, oh, I don't know why I did that, but whatever. You got it. Okay. Otherwise, we need to find out whether or not our guess was too high or too low. All right, so just to kind of get it back to where we were before, let's have the shrine say, try again for right now. So right now, this should have the shrine set the number, go through 10 times, and say you got it or try again each time. Okay, so as we see here, this could take, oh, finally we got it. 2 times in a row. All right, so this could obviously take a long time, especially if we had a larger range of values. So what we'd like to do is we'd like to allow the witch to kind of narrow her choices. So this was our homework. So this is kind of our starting point for our homework. Does that sound about right? Okay. So we're going to go ahead and throw a question in here. We want to ask the question. So if the shrine said try again, we want to also then ask the question, was the guess too high or too low? All right, so let's throw another if statement in here. So we're going to throw that question inside the else of this if statement. So after the shrine says try again, we're also then going to ask a question. The question we're going to ask is related to a whole number. We're going to say if the number was too small, if what number was too small? If the witch's guess, so which function get guess, if that was smaller than our shrine's get secret number, then we want to maybe print out, maybe the shrine says, your guess was too small, right? The guess was smaller than the number, guess was too small. So let's just have the shrine say that. So we'll have it say, too low. Otherwise, if it wasn't smaller, then it must be higher. So we'll have it say too high. All right, so let's go ahead and run this. And try again, too low. My guess is 3, try again, too low, so on and so forth. All right, so, well, we got it. Let's see if we make sure we have it too high. Come on, which? What was it, 8 or 9? Oh, it was 10? Is the answer? Oh, well, that's not gonna that's not gonna help us too much. Let's restart this. All right, there's our too high. 10 was too high. All right, perfect. So now we're gonna the shrine is accurately speaking whether it was too high or too low, but now we have to have a way of updating our witch's guess, our witch wants to intelligently update their guess. So one way you could do this is you could have the witch adjust the range of her guesses. So what we're going to do here is we're going to go in and we're going to add a couple of properties to our witch. So we're going to add a property to the witch. This guy's going to be a whole number. And we're going to call this guy min guess. And we'll start that off at 1. We're going to have another witch property called max guess. Whole number. And we'll set that off at 10. All right. So now the witch has two properties that start off as 1 and 10. So rather than having the witch generate a random number between 1 and 10, let's have the witch generate a random number between her min guess and her max guess. So we'll click on the witch, go to functions, get min guess, and get max guess. All right, something like that. Now, each time through, right now it's going to do the same thing it did before. We're just accessing the 1 and 10 through those properties, right? We're never changing those properties, so we should still have the same dealie here. Okay. So now what we'll do here is if we guess too low, then what we want to do is we want to adjust the witch's range. So if the witch's guess was too low, then what we need to do is we need to leave her high range, her max guess alone, but adjust her low range to be 1 greater than what her current guess is. All right? So if it was too low, then we're going to tell the witch to adjust her minimum guess. We'll just put a 0 in there for right now. And we're going to change this to a math function. To 1, well, actually let's do this. Her minimum guess is going to be whatever her current guess was, plus 1. That's going to be her new updated minimum guess. She was too low on her current guess, so we're going to make sure our next guess is at least 1 higher than what we previously guessed. All right? So that's what we'll do if our guess was too low. Similarly, if it was too high, then what we want to do is we want to adjust our guess to be 1, the maximum guess to be 1 smaller than our current guess. So we'll set max guess to be a math formula. And we want it to be a minus, right? To be whatever our current guess was, minus 1. All right, so think about this loop as being a filter. So we're going to do something 10 times. Each time through, we're going to generate a number between min guess and max guess. Then the witch is going to speak her guess. Then we're going to ask a question. If my guess was the same as the shrine's number, then we're going to say we got it. Otherwise, the shrine's going to tell us to try again, and then the shrine is going to give us some feedback as to whether it was too high or too low. So we have a question inside of the else of our original question. Okay? If it was too low, the shrine will say too low, and the witch will update her minimum guess accordingly for the next time through the loop. If it was too high, the shrine will say too high, the witch will update her next guess accordingly, so that the next time through the loop, when we spin back up here to the top, the next random number we generate will be based on a different minimum guess and maximum guess. Make sense? All right, so hopefully the witch gets the answer here within the first couple of tries, or 3 or 4 tries maybe. All right, so witch kept zeroing in on the, so now she's kind of stuck on that number. So she zeroed in on the actual guess. Now, one thing we'd like to do here, so was that the homework assignment? That did it? Okay. So questions about that. All right, so one thing we'd like to do here is, once the witch gets it correct, we probably don't want to keep looping, right? We'd like to kind of get the banter to shut up. So what we want to do here is we want to keep doing this over and over and over again until some condition happens. Now, one thing I don't know if we have the ability to do is, do we have the ability to break out of a loop? Most programming languages have a break function that would say, if something is true, go ahead and end this loop. Let's see if we have. Doesn't, unless is that set up as a prop or anything? No. Doesn't look like we have that. All right, so we're going to convert this to a while loop then, which makes more sense anyways. Did we start talking about the different types of loops? We talked about that. So last time we talked about kind of a rule of thumb from when we use a variable if we're going to use the value more than one time. So when we talk about loops, Alice supports a counting loop, do something some number of times, and a while loop. Is that the two that we see down here? So we have a counting loop, we have a while loop, okay, and then we also have a for each loop, which is going to go through a collection of stuff. We haven't looked at collections yet, so forget that exists right now. All right, so in typical programming languages, like Java, for example, we have two loops. We have a for loop, and we have a while loop. We actually have a third one called the do while loop. But let's just look at this. A for loop in Alice is going to be our count loop. Typically, for loops lend themselves to counting type problems where we know how many times we need to go through the loop. While loops lend themselves to problems where we do not know how many times we need to repeat. So in our world, right now we're using the equivalent of the for loop. We're doing something 10 times. We're making this assumption that we know how many times the witch is going to have to guess. As we've seen here, though, it's likely not going to take the witch 10 times to get the correct answer because she's adjusting her guess every single time. In fact, it's not possible for it to take her 10. All right, so we don't necessarily know how many guesses it's going to take though. So this while loop would be a more appropriate loop. Now both of these are what are called pre-check loops. Okay, so pre-check loops check the Boolean expression before executing the body of the loop even once. And what's a Boolean expression again? Any expression that boils down to a single value of true or false. All right, so that's that guy we use in an if statement. It's a guy we are going to use in our loops here. So we can think structurally, we can think of a while loop as being like an if statement that repeats. An if statement allows us to ask a single question and respond to the answer. A while loop allows us to ask a single question, respond to the answer, and then ask the question again until it's finally false. As long as it's false, as soon as it's false, we'll fall out of there and stop asking those questions. Okay, so while loops and for loops or count loops are pre-check loops. All right. The alternative is something called a post-check loop. In Java, we have something called a do-while loop, where we execute the body of the loop once, and then we ask the question. So we do something at least one time, and as far as I can tell, at least so far, Alice doesn't have the equivalent of that, unless there's more loops here that I'm not seeing. Let's count up to some number while something is true for each. Yeah, it doesn't look like we have those unless there's more stuff over here that I'm not seeing, but looks like that's the current state of things. So what we want to do is we want to keep creating a number. We want to keep creating a number, making the guess, asking if it's right, adjusting our values. We want to keep doing that over and over and over and over again until we finally get the right number. And then we're going to say we're done. Make sense? All right, so let's go ahead and bring a while loop out here. We'll start that off as true. Now, we want to keep going as long as the shrine secret number is not the same number as the witch's guess. All right, when we keep doing this over and over and over again. So this is going to be a whole number comparison. We're going to keep going as long as they are not equal to each other. That's this guy. So as long as these two sides don't equal each other, we'll just start them off as 0 and 0. And then we're going to replace, it's going to be the witch's guess and our shrine's secret number. As long as those two values are not the same value, we want to go ahead and do everything that's in the body here. So what's the first thing we want to do? Well, we want to get a new guess for our witch. Then what are we going to do? We're going to have the witch say her guess. Then what are we going to do? We're going to ask that whole series of questions. Make sense? All right, so let's get our count loop out of here. So as long as this is not true, go ahead and do all this stuff. Now, if I run this program right now, what's going to happen? Go ahead. Yep, it's not going to do anything. Because we initialize those two properties to -1. Right? When we haphazardly created our two properties, we just said, oh, let's just give them a -1. We're going to be changing them anyways. Well, this is a pre-check loop. So that means we're asking this question right off the bat. Is -1 not equal to -1? Well, they are equal to each other. So we'll fall past the loop and do nothing. Here, we'll let the shrine say something down here. Maybe gotcha or something like that. Go ahead and run this. Oh, hold on a second. Is that a... I was not expecting that. Oh, no, we're getting a secret number right off the bat because Oh no, we are okay. Because even though they were originally initialized to the same thing, we're guaranteeing that our secret number is not going to be -1 because we're generating a number between 1 and 10. So you were right though. I was wrong. If this line wasn't here, here, I'll copy that to the clipboard, then we'll delete it. Now if I run it, they are both -1 to begin with. So we're going to just see got you. There's the got you. All right, it's going to skip that whole loop. But as long as we guarantee that they change beforehand, we can do that. One thing we might do is we might decide to not rely on that default value since it's not obvious to us out here. And we might decide to go ahead and if the shrine is going to set the secret number to 1 to 10, go ahead and force the witch's initial guess to be something outside of that. So maybe we click on the witch, we click on the set guess, and maybe we initialize the guess to a -1. Even though we already know it's that value, now we visually see it's that value rather than relying on that initial value that we wrote when we first created the property. Okay, so we're setting the secret number, we're setting the guess, and we know for a fact these two numbers won't be the same because we are never going to get a -1 out of this random range. All right, so we know for a fact that we'll get into this while loop at least once. Go ahead and run it. So and the shrine's going to still say got you when it's over. Okay, so now we have this witch playing this game of the guessing game. Now we were also supposed to count how many guesses it took, right? Is that also part of the assignment? Not part of the assignment? All right, but that makes sense to do that? All right, so let's go ahead and have our witch, or could be the shrine. It's going to count how many times the witch got it wrong. So we're going to add a property to our shrine. And we're going to have this guy be a whole number. We're going to have this guy be guess count. And we'll start off at 0, but like I just said, even though it initialized to 0, since we don't visually see it, it's probably going to be beneficial for us to always actually initialize it. All right, so when our world starts here, the shrine's going to come up with a secret number, and the shrine is also going to go ahead and... Did I not actually create that property? Oh, I put it on the witch? Oh, good call. There we go. Select guess count. So when we first create this, we'll set the secret number, but we also want to go ahead and start our count off at 0 for the number of tries it took the witch to do. Okay? And then we'll go through and do all this logic. Now, every single time we get the answer wrong, we want to go ahead and increase the number of guesses, right? What about when we get the answer right? If we get the answer right the very first time, didn't it still take us 1 guess? So we actually probably want to increase the guess every single time the witch makes a guess. That guess may or may not be right, but we want to increase it every single time the witch actually makes a guess. Well, the witch makes her guess right here. So we can go ahead and have the shrine update the guess count to be a math formula. Something plus 1. And that something will be the current guess. Where's the value? Set guess count. Right there, that guy. All right, so we're going to set the guess count to whatever it currently is plus 1. And then in the end, instead of the witch saying got ya, we're going to change it to it took you, we'll change this to be something plus something else, and we're going to actually change the second one to be something plus something else. We're going to say it took you get guess count number of tries. All right, so we're effectively concatenating a bunch of stuff together. Okay, concatenation, did we talk about that last time? Gluing strings together. So we have the string, except it to you, took you. It took you concatenated with whatever the shrine's guess count is, concatenated with number of tries. Make sense? And we'll have that last for 2 seconds. So now we'll go ahead and have our shrine actually do some counting for us. Took you 5 number of tries. So really this should probably just say 5 tries, right? It's a pretty weird way of saying things right now. It took you 5 tries. Okay. So now we play the game. All right, so this stuff we're doing right here is effectively how a game is played, correct? Now if we look at our scene, here's the code for our scene, I think, right? Here we go. When the scene is activated, so if we go to this initialize event listeners, when that scene is activated, what we're doing is we're calling my first method, which is this dude that's over here that we wrote. All right? Well, we might call this method. Am I allowed to rename it here? Do I have to just create another one? Maybe I have to create another one. Okay, we might call this method play guessing game. So whenever we want to play the guessing game, we would play the guessing game. Does that make sense? So let's see if we can figure out how to rename this method. Can we do it here? Can we do it here? Rename. So we're going to call this play guessing game. All right. So the guessing game is going to exist between the witch and the shrine that are on the scene. And so anytime we play the guessing game, we're going to go ahead and do that. So we go back to this. Notice it changed it here to play the guessing game. And it referenced this. So it's the scene. So this is how an object refers to itself from within itself. So this, in this case, is the scene, because this is inside of the scene's listeners. And we'll talk about these listeners more later, because we can add more listeners to other things. All right, so when the scene first starts, it becomes aware that the scene was activated. This is kind of our first opportunity to do stuff related to our game. All right, and what we're going to do right now is we're going to tell it to play the guessing game. All right, now let's see. Can we go ahead and can we create a new function up here, or maybe is it one of these guys down here? How do we create a new function? In our scene, add function. Here, we'll add a scene function. So again, here's scene procedures and scene functions. In this case, this guy's going to do something, not return something. So we're going to go ahead and add a scene procedure. Okay. So we're going to add a new scene procedure. We're going to add a new scene procedure. I don't know if they let us do stuff with the witch's clothes or not. And we're going to call this guy set up scene. All right. And setting up scene is going to have us maybe tell the witch to do a couple things. You know, maybe the witch moves around, something like that. We could have the witch turn towards the turn towards the shrine. So maybe in here we'll go ahead and say have the shrine say hello for a second, and then we'll have the witch go ahead, and we're going to have the witch turn to face the shrine. All right. And so the witch is going to get a little bit freaked out here, so she's going to turn real quick. Right? Let's see, do we have an animation style too? Begin and end abruptly. Yeah, this is going to be like, military coming to attention type thing. Just turn, okay? So now let's go ahead and we're going to change this initial thing here. Instead of playing the guessing game, we're going to have our scene called setup scene and not play the guessing game. So right now our guessing game procedure is an untapped resource. This will make our witch and our shrine play a game, but we're never actually calling upon this procedure right now. We've written it, it does what it does, but until we actually call it, it's not going to do anything. Because when our scene first comes into existence, it's going to call this other procedure we wrote called setup scene. And setup scene is going to have the shrine say hello, and the witch turn to face the shrine, and then the witch could, let's see, we could make the witch say something. What do you want? Something like that. All right, so let's see what that looks like. And maybe we have that last for 2 seconds. And the witch is a little upset, so we'll make the outline color red. And we're not going to mess with anything else because I don't know what that's going to look like. So we'll go ahead and start this. Hello! Boom! What do you want? Okay, witch is ticked off. All right, so I wonder, can we actually make that? I'm interested here. Can we custom decimal number 0.02? That should be real quick. Boom. All right. All right. So now we want to have maybe the shrine say, "Do you want to play a game?" So we'll go ahead and do that. And then we'll have the witch say, "Sure." Or no, the witch will say, "I guess." All right, so a little bit less ticked off, but still ticked off. All right. So then, and just as a quick reminder, play guessing game. The shrine never actually says pick a number between 1 and 10. I think we had that last time, right? So let's just add something to that procedure real quick. So I'll go back into our procedure. We'll, right after we set the number, we're going to have the shrine say pick a number between 1 and 10. And this is a happy shrine, so we'll put it in light blue for a duration of 1 second. Good enough. All right, so then back here, as soon as the witch says, "I guess," then we're going to go ahead and start the game. Now, it's actually the scene that knows how to play the game, not the shrine. That make sense? The scene is governing this whole thing. That doesn't mean we couldn't have added this function or this procedure to the shrine, but we didn't. We put it in the game. So we're going to go ahead and ask our scene to do something. So I think we just click out here to this. This is the overarching scene, and we're going to tell it to go ahead and play the guessing game. All right. So now when we run this, hello, what do you want? You want to play a game, I guess. And now we go and play our guessing game. Took you 5 tries. Okay, so that makes some sense. So now we're kind of breaking up our application into modulars. So we have modules. So we have this idea called modular programming. So we want to break the problem down into small pieces that we can then call in a certain order or conditionally to solve the larger problem. Make sense? All right. So one thing we want to do is we want to keep breaking down those problems. Now, realistically for us here, it's not the scene that magically plays this counting game, right? So we want to start thinking about this like a movie scene. Okay. So the shrine is talking to the witch. They have some back and forth, and then when the witch says, I guess, the shrine is then going to respond by starting the game. Right now, the way that's working is the shrine is telling the scene, so it's like me, like let's say we're going to have an exam. So instead of me delivering the exam to you, I know it's bad thoughts, right? I'm going to ask the room to begin the exam. So I'm just going to sit back while exams fly out of the vents or something like that. Okay? Probably not the way things would work. Might be maybe a little weird actually, but in any case, when we're writing these things, we want to think about each of these objects. Okay, our witch is an object, our shrine is an object, the scene is an object as well, just like this room is an object and it's filled with people. Okay, and each of us has our own thoughts and our own hands and stuff like that, so we can do our own thing. But we're all in kind of a play together right now, right? We're all kind of talking, doing some stuff. So what we'd like to do is we'd like the shrine to play this game. Okay, so the shrine knows how to play a guessing game instead of the scene. And let's see if we can reassign this. I don't know if that's going to be in the cards for us, but the very least what we can do is we can click here on our shrine. We can add a procedure to the shrine. We can call this guy play guessing game. All right, so those are play guessing game. One thing I'm a little interested in here is, are we able to... Actually, I'm going to leave that there like that for right now because I want to be able to give you your homework assignment. So your homework assignment is not going to involve this. We're going to start working with parameters next time. Because when we have the shrine play the game, we're going to hand it the witch. And say, play the guessing game with this object. That way we can have the shrine play a guessing game with the witch. We can have a shrine play a guessing game with the dragon. Stuff like that, right? Right now it's just assuming the only other person there is the witch. So that's where we're going with this stuff. But what I want to do back here, just for your homework to evolve your thing a little bit and break it into 2 pieces, you'll create your setup scene function, which is going to do something similar to what we did here. All right. You'll go ahead and play the guessing game, and the game can be owned by the scene. Okay, but now what we want to do is we want to have the which react to the final outcome. And we're going to do this all inside of the play guessing game right now, and then we'll break it out next time. So what we need to do is down here, we're going to click on the which, and we're going to have the which do some stuff. All right. Is it place? Move and orient. We want to have the which move some stuff. But I don't think that's that. Is it point? All right, well, we can look into the exact next time, but effectively what we want to do here just to practice this stuff is we want the which to be happy if it took less than 3 tries. We want the which to be somewhat neutral if it took between 4 and 6 tries. And we want the which to be upset if it took more than 6 tries. Make sense? All right, so we're going to have a reaction in there. Later on, what I was going for here is the which kind of putting her arms up like this and saying something. And it's not that hard to do, but I can't find the function right now. That's this while loop right here. So the Boolean here in the while loop should say the which's guess not equal to the secret number. So, I mean, when we get into this if statement, if they are equal to each other, we're going to say you got it, but the next time it spins up, this is going to fail if they are the same. What you need to make sure you're not doing, where it might be... Well, my guess is, are you setting the guess again down in here? Or are you only setting the guess up top?